Hi, my name is Clement. I am so excited to be here. I'll be honest, my mind is still on Laura's talk and presentation, and then suddenly like, oh, it's me, and I need to speak now. And okay, so I'm going to switch gears quite a bit from the previous talk, and I'm going to zoom in really specifically about a subject in STEM education, which is about learning about electronics. And I'm going to talk a little bit about what we are doing in this space. And I promise I'm going to connect it to creativity, but that will be at the end of the talk, so bear with me. All right, audience participation. Can I have a show of hands? How many of you recognize this component on the screen? It's not to scale, just in case you're wondering. Yeah, okay, I see quite a few raised hands. Thank you so much. Does anyone want to shout out what this component is? Switch, right. Yes, it's a switch, or also known as a push button, right? And so this is a thing that you find in most of the electronic devices that you use, right? Essentially, if you want to press something, you want to activate something, you want to turn something on or off, you would have a push button. And the push button in a traditional electronics class, there we go. In a typical electronics class, the push button is what we call like lesson 01, right? It's like the first most fundamental thing that we teach students how to use, right? And essentially, in a typical electronics class, we would go through these existing components, right? Present-day components that are really useful, that we find all over, and then we'll teach students how to use it one by one and kind of go down this list. And so, for a moment, if I make this leap, right, creativity in this paradigm of learning about electronics really comes from being able to assemble, to know, firstly, these electronic components, and then to be able to assemble them in new ways. And so keep that in mind, and I want to talk today about a class that we have been running at NUS. It's a class that we run with Year 1 undergraduate industrial design students. It's led by myself, Akbar Yunus, and Yuta Nakayama, so it's a team effort. And we've been running it for the last 3 years. This is the class that we call Electronics as Material. And so what is electronics as material? Instead of teaching students how to use these prefabricated electronic components, we actually facilitate students to make these electronic components from scratch, from simple materials. And so if you think about a button, right, working principle, it's actually really simple. You have two electrical contacts and a bridge. When the button is pressed, right, the bridge short circuits these two contacts. Essentially, it closes a switch, and then electricity can flow, right? I think we have all learned this in primary school, some point or another, right? And so the working principle of a switch is actually really simple. So I'm going to teach all of you right now how to make your own switch, right? So first, you grab a piece of paper, and then you can actually get copper tape, is what they use for plumbing to fix some pipes. You can buy it at a hardware store. You get copper tape, and you can lay down your electrical traces, right? So this is one trace, here's another trace, and then we can form that bridge. Then we just take this piece of paper, we fold it, and now we have a switch, right? When I press down on this piece of paper, I have essentially created a push button that closes the electrical contacts, right? So open, close. I can like make my own gifs up here. So switch, push button, paper switch. So this is a prefabricated electronic switch that you'll find in like your electronic devices. And this is a switch that I just showed you all how to make. But this is also a switch, and this is also a switch that you can make. And therein lies the essence of this class, right? We are facilitating our students to learn about electronics through design, and actually by literally constructing everything, their knowledge and their understanding of these things from the ground up. And that's kind of the different approach that we're taking. And so, speaking a bit, putting on my administrative educator hat for a moment, we have 6 very precious weeks in this class. And so how do we do this curriculum in 6 weeks? First, we have an anchor project. So everything that the students are doing, they're building a game controller for Snake. How many of you have played Snake? I assume so, right? Nostalgia hit really hard when I was planning this class, and I was like, yeah, you know, I spent hours on this, I'm going to make my students spend hours on this as well. Actually, hours a day on this, right? So, okay, building a controller for Snake. Now, in the first week, in 1 week, our focus was on making it work. And so we introduced students to 3 different DIY components that they can build, right? So we have the push button, which I talked about. We also have a pressure sensor, and then we have a touch sensor. And then we front load all the content. So within 1 week, we teach students how to program these things, how to hook it up, how to essentially get it to work. And within 1 week, essentially, we get students to build that controller. So here are 2 examples of students making it work. I mean, the thing on the right is literally a Milo can turned into a joystick, right? It's not about like usability. It's not about aesthetics or the experience. Just be able to play Snake with the controller that you built. And this is done in 1 week. And then in 2 weeks, right, we shift gears a bit and we focus on, okay, now that you have made it work, can you make it clear? And so this is where we introduce things in human factors, things like affordances, like perception. Essentially, how do you get someone to use the thing in the way that you intend for them to use it? All of a sudden, when we teach this, the wires disappear, right? It's a much more presentable controller. But not just that, you begin to see things like arrows, symbols appear, color coding appear, right? Students were connecting not just like how the buttons, how the electronics were supposed to work, they were connecting it with how do I get people to perform the actions that I want them to perform, right? And so this is the second prototype that they have built, and it's only been 3 weeks. And then we spent half of the 6 weeks, right? We spent 3 weeks focusing on making it fun. And so we spend 1 week talking about working principles, we spend 2 weeks about human behavior, and we spend the lion's share of the class about the player experience. So how can students create an engaging play experience for the people playing their game? And this class essentially culminates in a game festival. So it's a game festival where we transform the classroom into a video game arcade. But it's a pretty weird video game arcade, right? Where there's essentially only one game, right? Which is Snake. But right, there are many, many different controllers for playing this one game, right? And of course, it's free of charge, right? People just come in, they play the game, and then they go. So I want to spend the next 3 slides just showing you some of the outcomes that came out of this class. So this is Serene. Serene was learning how to play the bass guitar when she was also taking this class. And she literally made like a real Guitar Hero controller, right? So I'm just going to play a video. Okay, incredibly challenging to play. I mean, I tried it. This is Kai. Kai was fascinated with the idea of using unconventional materials for electronics. And so at some point he realized that your citrus fruits, your oranges, your lemons, they actually are really conductive. I think we have all did that science experiment before. And so he essentially cut the fruits in half and used them as buttons, right? And so here's a snippet from... I have no idea why she's holding the knife like that, but yeah. So that's a juicy controller. And then finally, Kalinda. Kalinda did something really, really interesting. So Kalinda made the player the button, right? So essentially what the person has to do, what the player has to do is that they have to bang their head on the table in order to play the game Snake, which you can imagine is incredibly fun, but also maybe more funny for the audience than for the player. This guy was like the top scorer for all the games. Yeah. Now, what's really funny is that you're not looking at the screen when you are pressing the button, so you can imagine what happens. All right, so I began this talk, right, by talking about this electronic component, this push button. And I'm ending this talk by basically showing you a human being that push button. And so you might ask, right, it's all fun and games and it's all great, right, Clement, but what did you learn as an educator, right? What did I take away from this experience? And so I want to just maybe spend some time sharing about 3 different points about what I learned. And hopefully this could inspire, everyone here in the room today. So the first thing that really struck me and that was really apparent, right, is that making enabled learners to connect their passion to their learning. Serene was really into the bass guitar, maybe more into the bass guitar than the class that she was taking with me, right? But as she was thinking about the contents of the class and thinking about her experiences of making that push button, she realized that, okay, when I'm playing the bass guitar, I'm essentially pressing metal strings onto a metal fretboard on the neck of the guitar. And isn't that actually a push button, right? And so with that in mind, her whole idea of electronics just changed, and she's like, okay, so essentially I can just hook my bass guitar up with, alligator clips, and then I can just use the way I play the bass guitar as the way that I would interact with a push button, right? And so learners were really able to connect their passion to their learning. And the second thing is that making really enabled learners to critically question the technology that they were encountering for the first time, right? They were novices in electronics, but yet they were really able to critically question it. Kai's case, right? Kai actually had really strong feelings about electronics and electronic waste and how unsustainable a lot of our manufacturing practices are. And then when he realized that, hey, fruits could act like, citrus fruits, right, in particular, could act like buttons, I think it really flipped a switch, right? In this case, pun intended, completely. It flipped a switch in his head, right? And he began to see how we can actually be using more natural, more renewable resources in designing these technologies. The room also smelled really good when people were playing. And so what about creativity, right? The whole theme of this summit. What about creativity? Back to this. So this is that statement I made earlier about the current paradigm of interacting with electronics, right? Creativity comes from assembling electronic components in new ways. And just to connect a bit to what Laura was saying, right? I think a lot of times myself, how I've learned and how I teach, actually a lot of it is like trying to get students up to speed with present day, right? This is how our devices are right now, and I want my students to be as good as the people who built our present day devices, right? And hopefully, with that knowledge, they can build the next new thing, right? So creativity really comes from knowledge. But I want to flip this around, right? And so in the class, I think what was really apparent as well is that creativity didn't just come from knowledge, but creativity was also a pathway where students were learning. Creativity led to knowledge. And by making these controllers, students were actually learning and encountering electronics for the first time in very deeply personal ways with creativity. And so that's really the provocation that I want to end with, right? I think like many of you here, I grew up and I learned in a paradigm whereby knowledge led to creativity, right? I am constantly in the process of acquiring new skills, new knowledge, in hopes that I can be a more creative person with those new skills and knowledge. And what I'm trying to say over here is that there's also a space for us as educators, right, to create this environment whereby by being creative, students can actually learn what we are trying to facilitate. And maybe they might just do so in ways and connect it to things that they're passionate about. And they might also be able to not just think very practically about the knowledge, but they can also think very critically about this new knowledge that they are encountering. And so I'll leave you with that. That's it.